Hello students, in this session we will discuss direct and bending stresses in a retaining wall. So we will start with the steps that we need to follow to calculate maximum and minimum stresses at the base of retaining wall. After that we will discuss stability conditions for the retaining wall and then we will solve a numerical. So here is the cross section of retaining wall. So the area between point A, B, C and D represent cross section of the retaining wall. Capital A is heel of the wall and capital B is toe of the wall. Small a represent top width of the wall and small b represent bottom width of the wall. Capital H is total height of the wall and small h is height of the soil. Capital P is total soil pressure acting on the wall and W is weight of the wall. Capital R is resultant of P and W. So let's start with the steps that we need to follow for calculating maximum and minimum pressure at the base of retaining wall. So there are total 4 steps that we need to follow for calculating maximum and minimum pressure at the base of retaining wall. So let's start with step number 1. In step number 1, we will calculate total pressure P. Okay, this is total earth pressure. So total earth pressure P is equal to area of soil pressure diagram. So here you can see that the dotted portion represents soil behind the retaining wall and this triangle represents soil pressure diagram. Base of this triangle is WH into Ka and height of this triangle is H. So total area of this soil pressure diagram is 1/2 base into height, where base is WH into Ka and height is H. So we can say that P is equal to WH square by 2 into Ka. Okay. Here Ka is equal to 1 minus sin phi upon 1 plus sin phi and phi is equal to angle of repose of soil. Now let's move to step number 2. In step number 2, we will calculate weight of retaining wall, that is capital W. And capital W is cross-section area of the wall into density of wall material. Cross-section area of the wall is A plus B into H by 2 and rho is the density of wall material. So, equation to calculate weight of retaining wall W is equal to A plus B into H by 2 into rho. Now, let's move to step number 3. In step number 3, we will calculate eccentricity E. So, for calculating eccentricity, first of all, we need to calculate distance JK, where J is the point where W cuts base of the wall and K is the point where resultant R cuts base of the wall. Okay, so here is the equation to calculate JK. So JK is equal to P upon W into H by 3. Now we also need to calculate distance AJ. Okay, A is heel of the wall and J is again that point which W cuts base of the wall. Okay, so AJ can be calculated using this equation, which is A square plus AB plus B square upon 3 in bracket A plus B. Now we need to calculate small d and here is the equation to calculate small d. Small d is the distance between point A to K. So we can calculate d by adding AJ plus JK. Okay, so D is equal to AJ plus JK. Now, E is the eccentricity is equal to D minus B2. Again, D is the distance between point A to K. From D, we are deducting B by 2, which is X bar of this dam structure. Okay, so calculating eccentricity, we will use this equation. E is equal to D minus B by 2. Now let's move to step number 4. In step number 4, we will calculate sigma maximum and sigma minimum. And here are the equation to calculate sigma maximum and sigma minimum. So sigma maximum is equal to W by B in bracket 1 plus 6E upon B. And equation to calculate sigma minimum is equal to W by B 1 minus 6E upon B. So we need to remember all these equations to calculate numerical. So before calculating numerical, let's discuss stability conditions for retaining wall. So there are 4 stability conditions for retaining wall for which we need to check. Okay, so let's start with first stability condition. Here, first condition is no tension at the base. We know that retaining wall must be designed in such a way that there must not be tension at the base. And for maintaining no tension at the base, sigma minimum should be either greater than or equal to 0. Now we know that sigma minimum is W by B in bracket 1 minus 6E by B. So it should be greater than or equal to 0. So we can say that 1 minus 6E by B should be greater than or equal to 0. So 6E by B should be less than or equal to 1. So we can say that eccentricity E should be less than or equal to B by 6, where B is bottom width of the wall, okay, and E is eccentricity. So for maintaining no tension at the base of the wall, eccentricity should be less than or equal to bottom width of the wall by 6. This is also known as middle third rule. Now let's move to our second stability condition, which is no overturning. So the retaining wall must be safe against overturning. So for safety against overturning, resisting moment must be greater than overturning moment. Resisting moment is W into JB and overturning moment is W into JK. So we can say that JB should be greater than JK. So we can consider factor of safety against overturning. Then factor of safety is equal to resisting moment upon overturning moment, which should be greater than 1.5. So if we calculate factor of safety against overturning, and if it is greater than 1.5, then we can say that our structure or retaining wall is safe against overturning. So let's move to next stability condition, which is no sliding. Okay, so we know that the wall carries soil behind it and there is always possibility of sliding of the structure. And for stability against sliding, total frictional force at the base of retaining wall, which is mu into W, must be greater than total soil pressure P. Okay, so we can say that mu into W should be greater than P. In other words, we can say that mu into W upon P should be greater than 1.5. Here I am considering factor of safety. So if we calculate mu into W upon P and if we get a value greater than 1.5, then we can say that the structure is safe against sliding. Here mu is coefficient of friction between wall and soil. Now here is the last stability condition and it is no crushing at the base. Okay, so there must not be any crushing at the base, and for that sigma maximum should be less than safe bearing capacity of the soil. Okay, so these are the stability conditions. Now let's solve a numerical. So let's read data first. So a trapezoidal retaining wall of height 4.8 meter. Here H is the height of retaining wall. Capital H 4.8 meter is given. Retains earth up to top with its vertical face. It means retaining wall supports earth or soil for full height. Okay, so we can say that small h is also 4.8 meter. Now top width of the wall is 1 meter. It means small a is 1 meter and bottom width is 3.6 meter. It means small b is 3.6 meter. we need to determine maximum and minimum stress intensities at the base of the wall. So we need to calculate sigma maximum and sigma minimum. Take density of masonry as 20 kilonewton per meter cube. So here rho is given and rho is equal to 20 kilonewton per meter cube. Density of earth is 16 kilonewton per meter cube. So W is given, it is 16 kilonewton per meter cube. And angle of repose phi is also given, it is 30 degree. Okay, so these are the given data and we need to calculate sigma maximum and sigma minimum. So let's start with step number 1. These are the given data as we discussed. Okay. In step number 1, we will calculate total earth pressure P. And here is the equation to calculate P. P is equal to WH square by 2 in bracket 1 minus sin phi upon 1 plus sin phi. So value of W, which is density of earth, it is given 16. H is the height of earth 4.8 meter. Phi is 30 degree. So if I put all the values in equation of P, then I am getting P is equal to 61.37 kilonewton. Now let's calculate step number 2. In step number 2, we will calculate weight of the retaining wall. So W is equal to A plus B into H by 2 into density of wall material. Okay. So A means top width of the wall is 1 meter, bottom width is 3.6 meter, height of wall is 4.8 meter and density of wall material is 20. So I am getting value of W is equal to 220.8 kilonewton. Now let's move to step number 3. In step number 3, we will calculate eccentricity E. First of all, we will calculate JK. JK is the distance between point J and K, and here is the equation to calculate JK. P by W into H by 3. Where value of P as we calculated, it is 61.37. Value of W as we calculated 220.8 kilonewton. H is the height of wall, which is 4.8 meter. So I am getting JK is equal to 0.44 meter. Now let's calculate AJ. AJ is calculating using equation A square plus AB plus B square upon 3 in bracket A plus B. So value of A is 1, B is 3.6 meter. So if I am putting value of A and B in this equation, then I am getting AJ is equal to 1.272 meter. Now D is equal to AJ plus JK. So I am getting value of D is equal to 1.716 meter. Now eccentricity E is equal to D minus B by 2. Value of D as we calculated 1.716 meter. Minus B means bottom width of the wall is 3.6 meter upon 2. Okay, so I am getting eccentricity is equal to 0.084 meter. Okay, here I am getting minus value, and this minus value indicate that the stress at A means heel of the wall is more than at B, which is toe of the wall. Okay, now let's calculate step number 4. So in step number 4, we will calculate sigma maximum and sigma minimum. So let's first calculate sigma maximum. And here is the equation to calculate sigma maximum, which is W by B in bracket 1 plus 6E by B. Value of W as we calculated 220.8. B is a bottom width of the wall 3.6. In bracket 1 plus 6 into E. E is the eccentricity. As we calculated, it is 0.084 upon 3.6 is a B. Okay, so I am getting sigma maximum is equal to 69.92 kilonewton per meter square at point A, which is heel of the wall. Now let's calculate sigma minimum. Okay, so here is the equation to calculate sigma minimum, which is equal to W by B in bracket 1 minus 6E upon B. Value of W as we calculated, it is 220.8, small b is 3.6, eccentricity is 0.084. So I am getting sigma minimum is equal to 52.74 kilonewton per meter square at point B, which is toe of the wall. So as we discussed earlier, here value of sigma maximum is greater than value of sigma minimum. It is because eccentricity we are getting negative. So this is end of our session. Thank you.